Residential garages are typically classified as Group R-2, which is the classification for dwellings and similar buildings 3 stories or less in height. Regarding receipt storage height in residential garages, there is no specific code requirement in the International Residential Code, abbreviated IRC, or the National Fire Protection Association, abbreviated NFPA, codes that mandates the storage of receipts at a specific height above the floor in residential garages. The IRC does require the installation of smoke detectors in all sleeping areas of dwellings, including attached garages. However, there is no specific requirement for the storage of receipts or other items in garages to be elevated above a certain height. Commercial garages, classified as Group U, have stricter requirements regarding the storage of receipts and other flammable materials. NFPA 101, the Life Safety Code, requires that in commercial garages receipts and other flammable materials be stored at least 18 inches above the floor. Storage racks for receipts be constructed of non-combustible materials. Storage areas be kept clean and free of combustible debris. In understanding the electrical requirements for a residential garage, it's essential to consider the applicable sections of the National Electrical Code, abbreviated NEC, especially Article 210, which covers branch circuits. Firstly, general-purpose receptacles should be installed so that no point along the wall line is more than 6 feet, or approximately 1.8 meters, from a receptacle. This ensures convenient access to power for various tools and equipment. Secondly, at least one 20-amp branch circuit should be provided to supply receptacle outlets in the garage. This is typically a requirement for garages and ensures sufficient power for tools and equipment that may draw a higher current. Thirdly, all 125-volt, 15 and 20-amp receptacles in the garage must have ground fault circuit interrupter, abbreviated GFCI, protection. This is a critical safety measure to protect against electrical shock in damp or potentially wet locations. Consider the lighting requirements as well. Garages need sufficient lighting for safe and effective use. This typically includes general overhead lighting and possibly task lighting for specific work areas. The NEC addresses lighting requirements in Article 210 and Article 220, providing guidelines on the number and type of lighting fixtures needed. Regarding wiring methods, electrical wiring in garages must be installed using appropriate methods to ensure safety and compliance with the NEC. Common wiring methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and non-metallic sheath cable. The specific wiring method used depends on the construction type, environmental conditions, and local code requirements. It's essential to use wiring methods that are suitable for the environment and protect against physical damage. In addition, remember that any electrical work in a garage should comply with local building codes and regulations. These codes may include specific requirements for wiring, grounding, and bonding to ensure electrical safety. It's always best to consult with a qualified electrician to ensure that all electrical work is performed safely and in compliance with applicable codes. Also, the NEC provides guidelines on proper grounding and bonding techniques to minimize the risk of electrical shock and fire hazards. Grounding involves connecting non-current carrying metal parts of electrical equipment to the earth to provide a low impedance path for fault current. Bonding involves connecting all metal parts together to create an electrically conductive path. In addition to the general receptacle requirements, any specific appliances or equipment in the garage, such as electric vehicle charging stations or welders, may require dedicated circuits. These circuits should be sized appropriately to handle the load requirements of the equipment and comply with NEC guidelines. For instance, an electric vehicle charging station typically requires a dedicated 240-volt circuit with a higher amperage rating to provide sufficient power for charging. It's crucial to consult with a qualified electrician to determine the appropriate circuit requirements for specific appliances and equipment. Regarding the use of extension cords, it's essential to use them safely and responsibly in the garage. Avoid overloading extension cords and do not use them as a substitute for permanent wiring. Use heavy-duty extension cords that are suitable for the intended application and inspect them regularly for damage. Also, never run extension cords through doorways or under carpets, as this can create a tripping hazard and damage the cord insulation. When installing electrical outlets and fixtures in a garage, it's essential to follow proper mounting and installation techniques. Ensure that all outlets and fixtures are securely mounted and properly grounded. Use appropriate hardware and fasteners to ensure that the installation is safe and secure. Also, follow manufacturer's instructions for installation and operation. In addition to the electrical requirements, it's essential to consider other safety measures in a garage, such as smoke detectors and carbon monoxide detectors. Smoke detectors should be installed in all sleeping areas of dwellings, including attached garages, to provide early warning of a fire. Carbon monoxide detectors should be installed near sleeping areas to detect the presence of carbon monoxide gas, which can be deadly. Also, it's essential to keep the garage clean and free of combustible materials to reduce the risk of fire. Regarding the location of electrical panels in a garage, it's essential to ensure that they are readily accessible and not obstructed by storage or other items. The NEC requires that electrical panels have sufficient clearance in front of them to allow for safe access and maintenance. Also, electrical panels should be protected from physical damage and environmental conditions that could compromise their integrity. In addition, electrical work in a garage should be performed by a qualified electrician who is familiar with the NEC and local building codes. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in compliance with applicable regulations. Hiring a qualified electrician can help ensure that your garage electrical system is safe, reliable, and code compliant. When selecting electrical equipment for garage, it's essential to choose products that are listed or certified by a recognized testing laboratory, such as Underwriters Laboratories, abbreviated UL, or Intertek, abbreviated ETL. Listed or certified products have been tested and evaluated to meet safety standards and performance requirements. Using listed or certified products can help ensure that your electrical system is safe and reliable. In addition to the electrical requirements, it's essential to consider the structural integrity of the garage when installing electrical equipment. Ensure that the walls, ceilings, and floors are capable of supporting the weight of electrical equipment and wiring. Also, avoid drilling or cutting into structural members without proper authorization, as this can compromise the structural integrity of the garage. Regarding the use of surge protection devices in a garage, it's essential to protect sensitive electronic equipment from voltage surges and spikes. Surge protection devices, abbreviated SPD, can help prevent damage to computers, televisions, and other electronic devices caused by lightning strikes or power surges. SPD should be installed at the main electrical panel and at individual outlets to provide comprehensive surge protection. In addition to the general electrical requirements, it's essential to consider any specific requirements for electric vehicle charging stations in a garage. Electric vehicle charging stations require dedicated circuits with appropriate voltage and amperage ratings. Also, electric vehicle charging stations must be installed in compliance with the NEC and local building codes. It's essential to consult with a qualified electrician to ensure that your electric vehicle charging station is installed safely and correctly. Regarding the use of arc fault circuit interrupters, abbreviated FSIs, in a garage, it's essential to provide additional protection against electrical fires. FSIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. FSIs should be installed on branch circuits that serve receptacles in the garage to provide enhanced fire protection. In addition to the electrical requirements, it's essential to consider the environmental conditions in a garage when selecting electrical equipment and wiring. Garages can be damp or humid, so it's essential to use equipment and wiring that are suitable for wet locations. Also, garages may be exposed to chemicals and other corrosive substances, so it's essential to use materials that are resistant to corrosion. Regarding the use of tamper-resistant receptacles in a garage, it's essential to protect children from electrical shock. Tamper-resistant receptacles have a built-in safety mechanism that prevents children from inserting objects into the receptacle slots. Tamper-resistant receptacles should be installed in all areas of the garage that are accessible to children. In addition to the electrical requirements, it's essential to consider the energy efficiency of electrical equipment in a garage. Use energy-efficient lighting fixtures and appliances to reduce energy consumption and lower utility bills. Also, consider installing occupancy sensors to automatically turn off lights when the garage is not in use. Regarding the use of smart home technology in the garage, it's essential to enhance convenience and security. Smart home devices such as smart garage door openers, smart lighting controls, and smart security cameras can be integrated into the garage to provide remote control and monitoring capabilities. Smart home technology can help improve the functionality and security of your garage. In addition to the electrical requirements, it's essential to consider the long-term maintenance of electrical equipment in the garage. Regularly inspect electrical outlets, switches, and fixtures for damage or wear. Replace any damaged or worn components promptly to prevent electrical hazards. Also, schedule periodic inspections by a qualified electrician to ensure that your electrical system is safe and reliable. When performing electrical work in a garage, it's essential to follow lockout-tagout procedures to prevent accidental energization of circuits. Lockout-tagout procedures involve disconnecting power to the circuit and applying a lock and tag to the circuit breaker to prevent it from being turned on while work is being performed. Lockout-tagout procedures are essential for ensuring the safety of workers and preventing electrical accidents. The proper sizing of circuit breakers is vital for protecting electrical circuits from overloads and short circuits. Circuit breakers are designed to trip and interrupt the flow of electricity when the current exceeds the rated capacity of the circuit. Overloading a circuit can cause the wires to overheat, leading to insulation damage and potentially causing a fire. Similarly, a short circuit can result in a sudden and dangerous surge of current. To ensure safety, it's essential to choose the correct size circuit breaker for each circuit in the garage, based on the expected load and the ampacity of the wiring. The National Electrical Code, abbreviated NEC, provides guidelines for calculating the load and determining the appropriate size circuit breaker. It's also important to ensure that the circuit breakers are properly installed and maintained. Over time, circuit breakers can become worn or damaged, which can affect their ability to trip reliably. Regular inspections and testing of circuit breakers can help identify any potential problems and ensure that they are functioning correctly. Replacing faulty circuit breakers promptly is essential for maintaining the safety of the electrical system. Electrical boxes play a crucial role in providing a safe and secure enclosure for electrical connections and devices. They are typically made of metal or plastic and are designed to protect the wiring and prevent accidental contact with live electrical components. When installing electrical boxes in a garage, it's important to choose the right type and size for the application. Different types of electrical boxes are available for different purposes, such as surface mounting, flush mounting, and weatherproof applications. The size of the electrical box should be adequate to accommodate the wiring and devices without overcrowding. Proper installation of electrical boxes is essential for ensuring the safety and reliability of the electrical system. The boxes should be securely mounted to the wall or ceiling and properly grounded. The wiring should be neatly organized within the box and all connections should be made securely. It's also important to ensure that the electrical boxes are accessible for future maintenance and repairs. Conduit is a protective raceway used to enclose and protect electrical wiring. It provides a physical barrier against damage from impact, moisture, and other environmental factors. Different types of conduit are available, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. The choice of conduit depends on the specific application and the environmental conditions. When installing conduit in a garage, it's important to follow the manufacturer's instructions and requirements of the National Electrical Code, abbreviated NEC. The conduit should be securely supported and properly grounded. The wiring should be carefully pulled through the conduit without damaging the insulation. It's also important to ensure that the conduit is properly sealed to prevent moisture from entering. Wiring connectors are used to join electrical wires together safely and securely. Different types of wiring connectors are available, including wire nuts, terminal blocks, and crimp connectors. The choice of wiring connector depends on the type and size of the wires being joined and the specific application. When using wiring connectors in a garage, it's important to follow the manufacturer's instructions and the requirements of the National Electrical Code, abbreviated NEC. The connector should be properly sized for the wires being joined and securely tightened. It's also important to ensure that the connectors are suitable for the environmental conditions such as moisture and temperature. Grounding is a critical safety measure that helps protect against electrical shock and fire hazards. It involves connecting the non-current carrying metal parts of electrical equipment to the earth, providing a low resistance path for fault current to flow back to the source. This helps to quickly trip the circuit breaker or fuse, interrupting the flow of electricity and preventing a dangerous voltage from building up on the metal parts. In a garage, it's important to ensure that all electrical equipment, including outlets, lighting fixtures, and appliances, are properly grounded. This typically involves connecting a grounding wire from the equipment to a grounding electrode, such as a metal water pipe or a ground rod. The grounding electrode should be properly installed and connected to the earth. Bonding is another important safety measure that helps to minimize the risk of electrical shock and fire hazards. It involves connecting all metal parts of the electrical system together to create an electrically conductive path. This helps to ensure that all metal parts are at the same electrical potential, reducing the risk of a voltage difference that could cause a shock. In a garage, it's important to ensure that all metal parts of the electrical system, including conduit, electrical boxes, and equipment enclosures, are properly bonded together. This typically involves using bonding jumpers or bonding screws to connect the metal parts. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. They are an essential part of the electrical system and help to prevent damage to the wiring and equipment. Circuit breakers are automatic switches that trip and interrupt the flow of electricity when the current exceeds the rated capacity of the circuit. Fuses are one-time devices that melt and break the circuit when the current exceeds the rated capacity. When selecting overcurrent protection devices for a garage, it's important to choose the correct size and type for the specific application. The size of the overcurrent protection device should be based on the ampacity of the wiring and the expected load of the circuit. The type of overcurrent protection device should be based on the specific requirements of the equipment being protected. It's also important to ensure that the overcurrent protection devices are properly installed and maintained. Regular inspections and testing can help identify any potential problems and ensure that they are functioning correctly.